All right, guys, welcome to lesson 8.2. We're going to talk about graphing exponential functions. I'm going to be breaking this lesson up over a period of 2 days, so this is part 1. We're going to begin by basically, the basic idea is we want to learn how to graph these, and part of the process is learning how to find the y-intercepts and a horizontal asymptote. Another thing we're going to do is we're going to learn how to describe their end behavior, like we did with polynomials and rational expressions. So let's go ahead and jump on in here. So on this slide here, I've given us a exponential function up here at the top. Just to review with you, it's an exponential function because the power is the input variable. Okay, so let's go ahead and begin. We're going to just do some analysis as we work through these problems, and that'll lead us to a process where we can kind of graph these things easily. So the first few slides we're going to look at is just doing a couple of examples, and then we're going to come to some conclusions, and as a result, we'll have some nice steps to go through to get some graphing done in a little bit of an easier fashion. So let's go ahead and begin with the analysis here. So question 1 for this particular exponential function, is this function increasing or is it decreasing, and why? Well, if you want to know if it's increasing or decreasing, you're going to look at the value of b, and if that value is greater than 1, like it seems to be, then that means it is increasing. So since b, which is equal to 1.5, is greater than 1, the function must be increasing. Okay, so that's something that we want to be aware of there. All right, let's go ahead and continue on with our little journey here. Complete the table below. Now, for most of these, I'm just going to use my calculator. But for 0, I'm going to not use my calculator, and that's because I want you guys to see something here. So basically what I'm going to be doing is I'm going to be plugging these numbers in for x, and as a result, we're going to get an answer for y, and we're going to put it here. After that, we're going to have a bunch of points that we can connect together to kind of get an idea of what the graph of an exponential function looks like. So like I said, we're going to use the calculator for most of these. However, for 0, I actually just want to go ahead and do it by hand. So here we go. Let's do that by hand. 1.5. I'm going to plug 0 in for x. And what's interesting about this one is that it works out really nice. Anytime you raise something to a 0 power, it equals 1. So 1.5 to the 0 power equals 1. That's it. It doesn't matter what number is there. Anytime you raise something to a 0 power, it's going to equal 1. And then we simplify it and we get 3. And that's what I'm going to put right here. Now, before I go on and find the rest, what I want to point out to you guys is that that finds us a specific point on the y-axis, 0, 3. That would be like maybe if this is 20, this is 10, 5 would be right about here. So 3 would be somewhere like right about here. So what I want you guys to what I want to point out to you here is that when you plug in 0, you basically just end up getting this number as your answer. And that number happens to be your y-intercept. So that's the first aha moment I want you guys to take away from here, is that the number a in the front here, the a number, that actually is just going to end up being a y-intercept for today. Now, in our lesson tomorrow, it's going to be a little different, but for today, the a tells us our y-intercept, okay? Now, for the rest of these, we're going to go ahead and just plug it into our calculator. So let's go ahead and do that. All right, and so these are the answers I get. So go ahead and record these down, and if I were you, I would make sure that you try one of these at least on your calculator by plugging in, like, let's say, -10, for instance. And for the negative ones, make sure that you do know the difference between the negative button and the minus button. Sometimes on these calculators, there's a negative button, and sometimes there's a subtraction button. Those are different things. The negative button is the one down at the bottom. But anyway, make sure you work this out so that you get these solutions. And the next thing we're going to do is we're going to plot these points. Now, I've already plotted 0, 3. I put that right here. Let's plot another one, 1 and 4.5. So over 1 and up 4.5, which if this is 20, this is 10, and so 5 would be in the middle. So 4 would be just barely higher than that. almost difficult to tell. And then we have 5 is 22.8. So I'm going to go over to 5 now, and I'm going to go up to 22.8, which I would estimate to be like maybe like right about here. And then 10 is 173, so I'm going to go over to 10, and that takes me all the way up to 173. So it grows really fast, and that's how exponential functions are. They grow pretty quickly. All right, so it's going like this, it seems. Now let's look on the other side. The other side is a little bit strange. Let's do -1, 2. So -1, 2 would probably just be a little bit lower than where the 3 was before. So like probably like right about here. And then -5, -0.4. -5, -0.4. Well, 1 would probably be like right about here. So it's almost difficult for us to tell where it's at. It's so low next to that black line. And then at -10, it's still... Actually, I just realized I have some errors here. This needs to be fixed. These are not negative. That was a mistake. Should not have gotten negatives here. That was a boo-boo. There we go. So I had a mistake. I accidentally made these negative, and they're not negative. They're supposed to be positive. So at -5, we're at 0.4. And then at -10, it's 0.05. Now, that's not 0, but it's really, 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 really close to 0. In other words, it's almost on that black line, but not quite. And at this point, really, we can't really make a dot that's small enough to represent it, but there it is. Now, I just want you guys to know that when it comes to these exponential functions, especially the ones that we're going to be doing today, they have what's called a horizontal asymptote. That means there's a horizontal line that they cannot cross. And for every problem we're going to do today, it's going to be the x-axis. So what's happening is that on the left side of my graph, it's going to be getting closer and closer and closer to this dotted red line that I'm drawing right now, but it won't ever actually touch 0. And you could test that yourself. You could plug in -100 here, go even really far to the left, and you still won't get 0. You'll get a really, really, really small number, but it will never cross 0. And so we have a graph then that looks something like this. It's really flat on this side. You might as well just make it touch the dotted line, even though it doesn't, because it's so close. And then it slowly creeps up, and then it shoots up after that. And that's what exponential functions look like. So they basically have they're really flat on one side, and then they shoot up really fast on the other. And they have a Y-intercept, which matches this number in the front here. Oh, I'm on the wrong slide still, actually. There we go. And there it is. So we've learned two things then. If this number is greater than 1, it's increasing. We've learned that whatever this number is, that's the Y-intercept. And from this table, we've kind of see the shape of an exponential function. And we've also seen that they end up having a horizontal asymptote at 0. Okay? And so I've already done step 3, which is to graph the points and sketch the graph, and there it is. So by doing this problem, we've kind of discovered a few things about exponential functions. Let's go ahead and take a look at another one here. This time I would like you guys to do the problem on your own. So let's go ahead and have you do this one. So go ahead and complete this slide. When you're done, go ahead and unpause the video and look at it, compare your answers with mine, and then we'll see if we can iron out any differences. So for this particular problem, we see that it's decreasing because the b value is 0.7, which is less than 1. And here's the table values. Notice in particular that when x equals 0, the y value is 4, because as I said, that's the y-intercept, which is this number here, located right on the y-axis. And I've plotted all my points as well. I haven't connected them yet. Let's go ahead and do that now. And so you guys can tell that this graph looks a little bit different. So we still have a lot of the same stuff going on. This still represents my y-intercept. We still have a horizontal asymptote. The shape is the same, but you'll notice that it's going in a different direction. It's like flipped. The other graph went like this, and this one's going like this. Well, why is that? It's because the graph is decreasing. So if you have a b value that is less than 1, then it gets flat on the right side. If you have a graph where the b value is greater than 1, it gets flat on the right side and then shoots up. Okay, so that's what we've come to realize after all of our analysis and practice here. So let's go ahead and look at our conclusions then. So if you have an exponential function of this form, then the value a is the y-intercept. There's always going to be a horizontal asymptote at y equals 0 for today. You'll find out tomorrow that's not going to be the case. And as a matter of fact, same thing with the y-intercept. The y-intercept will also be found a little bit different next lesson. But for today, the a represents the y-intercept, and the horizontal asymptote will always be at 0. That's the horizontal x-axis. So y equals 0 is the x-axis, just so you know. We've also saw that if b is greater than 1, then the graph goes like this. And if b is less than 1, then it goes like this. So this is an increasing function. This is a decreasing function. All right. And those are all of our conclusions. And now we have enough information to kind of be able to graph these without having to do tables. So the purpose of the tables, once again, was just to kind of show you guys how to analyze the process. But now that we've done the tables, we now have a faster way to graph them without using tables. And that's what the rest of our lesson today is going to be focusing on. And the rest of our lesson is going to be how I really want you guys to go ahead and be graphing these today. So let's begin. So first of all, it says, identify and sketch the y-intercept. Well, we already know that this number here in the front is my y-intercept. So I'm going to draw a graph. I'm going to go up 2 on the y-axis, and I'm going to put a dot there. That's my y-intercept. So step 1, identify your y-intercept and then plot it. Step 2, identify and sketch the horizontal asymptote. Well, as we said before, today the horizontal asymptote is always going to be the line y equals 0, which is basically the x-axis. So I'm just going to highlight the x-axis, and that green highlight is going to represent my horizontal asymptote. The next thing I'm going to do is I'm going to determine if the function is increasing or decreasing, and then I'm going to sketch my graph. So notice that b is 2.3, and in that case, b is greater than 1, because 2.3 is greater than 1, right? So I've got an increasing function, and when you have an increasing function, your graph goes up like that. And so we're going to be flat on this side. It's going to come up and hit that y-intercept, and then it's going to go up on the right side. And that's it. So we've got a graph, and we did that without having to use a table. And that's how we'll be graphing them for the rest of the day. Now you guys will notice here that I've included some extra information down here in parts D and E. This is end behavior stuff. So you might want to label this on your notes, because I didn't call it that on your notes, but it will be worded that way on our classwork. So you might want to label this as end behavior, these two things. Okay. This is using limit notation to describe the end behavior. Now it's been a little while, so I'll remind you. When x is approaching infinity, that means what's our graph doing on the right side? And when x is approaching negative infinity, that means what's my graph doing on the left side? Well, let's take a look. What's happening on the right side of my graph? Well, it's going up forever, so that's infinity. What's going on the left side of my graph? Well, it's not going down into infinity. It is, but it's getting closer and closer to this green line always. And that green line is 0. So this is new. We've always had infinities before, but now we've got a 0 here. So on the left side, that's where it's getting flat against the line y equals 0, and so that would be the y value on that side. So on the right side of my graph, my y value goes up, so I put positive infinity. And on the left side of my graph, it's getting flat against the line y equals 0, so my limit there would be 0. All right, let's go ahead and take a look at another example. Example 2. Now you're going to notice that we're missing something here. Do you guys notice what's missing? I've got my b. Where's the a? Well, if there's no a there, it's O1, just so you know. So be aware of that. Let's go ahead and begin. So what do you guys think? Identify and sketch the y-intercept. I would encourage you guys to pause the video here and give that a try. All right, so the y-intercept is that number I just added. It's the 1. So I'm going to go ahead and draw a graph, and I'm going to put a dot at 1. So there's my y-intercept. So that's done. Let's go ahead and identify and sketch the horizontal asymptote. Well, once again, today the y-intercept, the horizontal asymptote is always going to be y equals 0, and therefore it's always going to be the x-axis. So we're just going to draw a line there. Next, determine if the function is increasing or decreasing. Well, in this case, my b value is less than 1, which means that it is decreasing. And when you have a decreasing graph, it goes like this. It gets flat on the right side and it goes up on the left. So that's going to look something like this then. Now let's go ahead and do our end behavior. What's happening on the right side of my graph? Well, it's not going up, it's not going down, it's getting flat at 0, so that would be 0. What's happening on the left side of my graph? It's going up, so that would be positive infinity. Okay, so it's opposite from the last one, and that's because the graph is going in an opposite direction. Let's go ahead and take a look at our last example here before I give you guys some student practices to mess around with. What's my y-intercept? It's 5. There's that. My horizontal asymptote, 0. Increasing or decreasing? All right, well, look at this number. Is this number bigger than 1 or less than 1? It might help if you change this into a decimal. If you do the top number divided by the bottom number on your calculator, you're going to get 1.5. And so the answer is 1.5. So just as a rule of thumb, anytime the top number is bigger than the bottom, you're going to get an answer that's bigger than 1. But if the top number is smaller than the bottom number, that means the fraction value is less than 1. But in this case, I get 1.5, so that means b is greater, which means that I've got an increasing function, which means the shape is flat on the left and goes up on the right. And so that would be like this. So what's happening on the right side of my graph? It's going up, so that would be infinity. What's happening on the left side of my graph? It's getting flat against 0, so that would be 0. All right, let's go ahead and move on to another one here. So this is student practice. Why don't you guys go ahead and pause the video here, do parts A through E, and when you unpause it, you'll see the total worked out solution. So this is one of those problems where there's a missing A, so we know that's a 1, which means that's my y-intercept. Horizontal asymptote is still at 0. B is 4, which is greater than 1, so we have an increasing function, which means it looks like this, which means we're increasing on the right, so that's infinity, and we're flat on 0 on the left, so that would be 0. Let's go ahead and take a look at 2 more student practices. Go ahead and pause the video here and try this one. When you unpause the video, you'll see the solution. So my y-intercept on this one is 5/2, which if you change it into a decimal by dividing the top number by the bottom number, you get 2.5. So that would be this dot right here. When I graphed it, I didn't touch it. That was an accident. It should be going through that dot, but it didn't. My horizontal asymptote is here as always. The b value is less than 1, so that means we have a decreasing graph like that, which means on the left side of my graph, it's going up into infinity, and on the right side of my graph, it's flat at 0. All right, one more student practice, and that should do us for the day. Go ahead and pause the video here and give A through E a try, and that'll do it. Okay, so on this problem, my y-intercept is 3, so I've got my dot here at 3. Horizontal asymptote is on the x-axis as always. This number is less than 1 because the top number is less than the bottom. So if you divide it, you're going to get 0.75, which is less than 1, and therefore that's a decreasing function, which looks like this. So on the right side of my graph, it's 0, and on the left side of my graph, it's going up into infinity. All right, and that does it for the day. So hopefully that was helpful, and we'll see you guys in class.